I'm just going to go. Okay, so hopefully you can see the presentation here on screen. Right, so the title of the talk today is Joint PhD Supervision Across the Run EU Alliance, and it's a case study. Another case study coming up after this. What I'm going to talk about really is how the project came about, our experience so far in terms of supervision, and the part Arpan will deliver if he's here is some of the technical bit based on the work that he has done so far. If he's not here, I'll jump in and try and present and do my best to present his work for him, and we'll go from there. Okay, so it's broken in sections. I was going to do a bit at the start, Arpan in the middle, and come back to me. So just a little bit about me, I suppose, on the project. I'm working in TUS in Ireland. I'm in Department of Civil Engineering, and I'm in the Midlands campus. You probably all know that we have two campuses, the Midlands and Midwest. So we're working up here in the little red bit at the top. And this project is co-supervised and work carried out with ICARUS. So ICARUS is based in Portugal. So roughly, as the crow flies, it's about 1,500 kilometers between the two institutes. But if you're trying to travel there in any way, it's about 2,500 kilometers. So we're quite a bit apart, and we're probably working away on our own for the last while. So on my own side, I'm the director of the Sustainable Infrastructure Research Group in TUS, and that's a small but developing research group. And it's comprised of staff and postgrad students. We have 4 PhD students at the moment and a couple of academic staff who are actively researching as well. We work generally in the area of sustainable infrastructure and the circular economy, particularly in relation to the built environment. So we're looking at things like sustainable concrete technology, digitization of construction processes, innovative construction materials and processes, and quality management in construction. So that's the sort of the remit or the description of our research group, and they're the activities that we're carrying out at the moment. Then separately, there is a research institute in ICARUS. It's CDRSP, which is an acronym for the Center for the Rapid and Sustainable Product Development. And it's a similar structure in that it's made up of staff and postgraduate students. And the areas that they research are emerging technologies, generally, advanced materials, and sustainable manufacturing and manufacturing of green technologies. So you can see there's a bit of overlap and a bit of synergy, particularly in terms of the emerging technologies, advanced materials, and the sort of green agenda, which is driving a lot of research centres at the moment anyway. So, as I said in the previous slide, we're about 1,500 kilometres apart. We're working away doing our own work, and we have TUS on one side and ICARUS on the other, and up to about 6 months ago, we'd never met. Up to about 2 years ago, we probably hadn't even heard of each other. So we needed some sort of an introduction. So the introduction came along. We got our own nice little cupid to bring us together, and that introduction was Run EU. So the program brought the institutes together generally as part of the Run EU network, and then obviously through Run EU Plus, there's funding for the research programs that have spun out. So that's managed to bring us together in a way that's proven very fruitful for both of our research centres so far anyway. Exactly how it happened, there was a TUS Run EU PhD scholarship call last year. And what happened, first of all, I was contacted by Arpan, Joshi, who's a researcher in ICARUS, and to see if would be interested in co-supervision and a joint application for research funding. So we had a couple of meetings with Arpan, and our supervisor is based in Leiria, who is Fernando Gaspar, and we worked out scoped out a project, and we submitted an application. The application thankfully was successful, so we got some money and we got approval to run the project. And Arpan then started work in October 2022. So just a couple of months ago, he officially started his work. Now, Arpan, I suppose, is not your typical PhD student, which is what we're seeing, I suppose, a lot through this network and more recently. Arpan was actively working as a researcher in IPLARIA, so he's actively involved in work already. So he's bringing a lot. He's hitting the ground running in terms of his PhD. So you'll see from the work that's presented shortly that for somebody who's only 2.5 months into a PhD, there's quite a bit of work done there already. So it was a great start, and it's great to be able to present some technical information now at this stage. What I'll try to do with the technical bit as I move on, I'll try to keep it that it's not too technical and not too specialized, and hopefully just get a flavor for the amount of work and the type of work that Arpan is doing. So that's just a background to the project. I suppose I'm going to go on now and deliver the technical bit, and then I'll come back and I'll just give you a few of my thoughts on the sort of the experience as well of supervising the project. So Leiria, as you probably know, is a beautiful city. It's a small city in Portugal, relatively small, and I have never seen Leiria. All of these pictures came from their website because I've never been there. So this is one of the joys of co-supervision and remote supervision, which is certainly new to me. We are hoping, obviously, for some exchanges throughout the project, but as things stand, I've never been, and Arpan has never been to Athlone either. So our meetings generally look like this. This is about the best view I have of Leiria. Normally Florinda would be here as well. He just wasn't at our last supervision meeting. But as you can imagine, a lot of it is done remotely. A lot of Zoom calls really are how we're communicating. So it's one of the upsides, I suppose, from the pandemic, that it's enabled us and given us confidence to do this kind of work remotely. Okay, so on the research to date, then, this is the section that Arpan will hopefully present. I should point out that Arpan is from Nepal, and he has gone home for a few weeks holidays. So he is in Nepal, and there are some connection issues that he's having from our meeting. So hopefully he'll be able to join us at some point, but if not, I'll keep going. Okay, so the title of this work so far is Incorporation of Forest Biomass-Based Fly Ash in Cement for 3D Printing. Okay, so our research project generally is looking at incorporating sustainable materials into cement or into concrete that's suitable for 3D printing. So it comes from our two separate backgrounds, I suppose. In CDRSP and Leiria, they've experience in 3D printing. They have facilities there to carry out 3D printing and concrete, which we don't have yet. On the other side, we have a lot of experience in terms of organic and organic materials in concrete, as a way to try to reduce the carbon footprint and the embodied carbon in concrete. So we brought them together, and we're looking at trying to use some of those sustainable materials to replace some cement in concrete that is suitable for 3D printing. So that's the general aim of the project. So what Arpan has done first is he has looked at a simple replacement of some of the cement content from this fly ash, which is a waste product from burning biomass material. So the early work he's looked at, we talked about the research motivation, and he talked about the Sustainable Development Goals and European Green Deal, lots of international policies which are driving the circular economy, particularly in the built environment. We're looking for ways to reuse materials. We're looking for ways to reduce carbon, and try to make the construction industry more environmentally friendly, to put it simply. So generally, concrete is the most common building material in the world, and 1 ton of cement generates about a ton of carbon dioxide in its production. An awful lot of that production goes into the production of the cement itself, which is then embodied in the concrete, which, when we look at in terms of a circular economy, it's embodied in the concrete, which goes into our structure, and depending on the life cycle of our structure, we do a full life cycle assessment. If that concrete can be reused at the end, it's one thing. If it can't, it's another thing. How does that get disposed of? So there's a general aim to try to reduce as much as possible the carbon that is embodied in concrete. Separately, we've got a lot of development recently in the area of 3D printing of concrete. So it's very much an early stage research area. 3D printing is well established for other materials, but for concrete, it's in its infancy. So there's a lot of work going on to try to optimize concrete mix designs that the concrete is suitable for printing. So it has to have correct rheological properties so that it can be extruded out of the apparatus, and then also that it will set quickly enough to maintain its shape. That's so you have a kind of a contradiction that we want the concrete to be fluid, but then has to set quickly, which is changing how concrete has been looked at for well traditionally for a long time. So we're trying to look at developing the 3D concrete, make it usable, so make it viable for 3D printing, but also trying to reduce the carbon content. So the first thing we're going to look at here is as a cement replacement is BMFA, biomass fuel ash, or biomass fly ash. So why biomass fly ash? Well, or what is biomass fly ash? Biomass basically is any organic material that's used for energy production. We have some examples here. This work is based on a Portuguese study that Arpan was involved in, and we see it ourselves in Ireland. There's and very close to our own campus in TUS. There's a power station that's run by Bord na Móna. It's a state agency, and they traditionally burned peat, and they've recently switched to biomass, and they're now 100% switched to biomass. So they're no longer burn peat, but they're burning biomass. They burn that to generate the electricity, but as they do, as they burn it, we're left with this waste product. So we have this waste product down here, and this is the fly ash, and this is the ash that's collected from basically the chimney towers in the power station. So this is what's left. So what we're trying to do is to see if this fly ash can be used to replace at least part of the cement, because fly ash exhibits some similar properties to cement. So on one hand, it reduces the waste, so it helps to manage the waste. One of the problems of burning is this waste generation, and on the other hand, it will reduce the amount of cement that's needed for a particular amount of concrete. So it's a double-edged sword. There's benefits in both ways if this can work. Okay, so the objectives of this part of the study were to utilize the waste as a partial replacement of cement at different proportions, to see was it suitable for 3D printing. To see what's suitable, we have to look at the rheology. The rheology is basically how the material will flow under stress. So we have to treat the concrete as a fluid material under stress, and we have to see how that works. We have to understand the relationship then between different mechanical properties, yield, stress, plastic, viscosity, etc., on the printability and buildability of the concrete. We have to understand the pumpability and workability of the mortar by increasing the content. So basically what we're doing is we're looking at the cement. We're trying to partially replace some of that cement with this fly ash to see how the properties of the concrete change. We don't want to negatively affect the final properties of the concrete, or indeed the early stage properties, which are the rheological type properties, but we want to see is it possible to do this. So first off, we have to characterize and assess the fly ash as a material itself. So this is just a simple characterization of the size, the particle size. So we have about 50% past 123 microns. And then with the chemical composition of the biomass by percentage, and you see there's a lot of these oxides in here. So that means that we can classify this as what's called a class F pozzolan. So pozzolan means that it will react. There's a pozzolanic reaction and give us a binder material that works similar to cement. So we can do that if the content is above 70. So when we add these three together, we get above 70. So it's a class F pozzolan. So that's good news for a start. So that means we can look to use that as a cement replacement. So Arpan did work where he looked at, this was a basic mix, so not to get too technical, the cement, sand and water are the main things that go into it. Obviously then, because we're looking at rheology, we add in a super plasticizer, which stops the concrete from setting too quickly, so it allows us to manipulate the concrete a bit more. Arpan made up several mixes. He measured the rheology then using this torque sensor. It's basically a vane, like similar to a shear vane, which rotates around inside the vat here, and we can measure the stress and we can measure the performance of the material inside there. Then we have a setup for 3D concrete printing. We just have our batcher here. We have this is our 3D printer here. It's an extruder, has a nozzle, and this is printing just a concrete product here. A lot of advantages of 3D printing, you can look at very fluid shapes in concrete, which you might be able to see in this one here. There's lots of curves that we wouldn't typically generate with traditional concrete methods. I'm just going to see if there's a short video here, just shows the printer in action, if it will work. If not, we'll skip on.
Paul, about 4 minutes, okay?
Yeah, okay, no problem. Yeah, so we'll skip the video, and but basically some of the things we had to look at were buildability. So buildability is the ability of, so you can see from this picture here even the printed layers of concrete. So the buildability relates to the thickness of the layers that we can build without the concrete collapsing before the next layer is built. So we look at the maximum height printed before collapse. That's really what we're looking at there. Okay, so results and discussion, again, I'll try not to get too technical with it. I know we're all from different backgrounds here. So what we saw is that the slump flow, so that measures how the concrete reacts or behaves as a fluid, would increase in replacement of cement up to about 20%, and then it drops off. So the more of the fly ash we put in, the more it behaved like a fluid. If we kept the water constant, when we go beyond 20%, you can see it decreases, which meant there's a decrease in workability, a decrease in the suitability for it to work as a 3D printing material. If we kept the slump, so in other words, how if you like, how stiff that fluid concrete is, if we kept that constant, we saw that we needed more water as we increased the percentage of fly ash. That's just something to be aware of. When we add more water in, typically we get a decrease in strength. So that's the challenge we're faced with. If we're going to keep it at a certain stiffness or certain rheological properties, are we going to see a drop off in strength by adding more water? So there's a few challenges that come out of these early results. Again, we see in terms of the yield stress, there appears to be an optimum value of around 20% replacement of fly ash. Then it decreases off. So from early work, it looks that we can replace up to 15 to 20% of the cement with fly ash without having any negative effect on the concrete, and in fact having a positive effect on the concrete behavior, which is really good. The buildability, it starts to reduce with increasing fly ash, which just probably indicates that it takes longer for the concrete to go off, so we would have to build in slightly thinner layers, or we'd have to change that mix a little bit to try and help that. So some conclusions there. So for early stage work, it's really promising, and Arpan has done an awful lot in this. So future work then relates to the longer term in the PhD. Want to get a better understanding. I want to drill down into this a little bit more, see can we optimize the value of the fly ash replacement, and also see if we can use some additives, some polymers maybe to keep that fly ash content quite high and improve the general rheological properties of the concrete. Okay, so I'm going to hand back to myself now, and just a last little bit about where we started was this initial idea of co-supervision of a PhD project, which has worked out quite well. We're moving on past it. Florindo and I we've just been invited to be guest editors of the special issue of a journal. The journal is Sustainability, so we're working on that at the moment. One of the things we possibly will do from Arpan's work is look at a short advanced program, developing a short advanced program in the area of 3D concrete printing. And there's a framework in place now for further PhD students. So the apprehension that was there at the start about working with someone that you'd never met and working remotely is probably past. It seems to be working very well from my perspective, I think Florendo would agree, and I think Arpan is doing quite well at this, and well, Arpan's doing excellently in terms of his progress. So I think he's happy enough with the arrangement as well. So next steps, we do have funding as well. Arpan has secured funding for a visit. Most of his work is going to be based in Leiria, but he is going to visit Athlone because we have some facilities that they don't have, or some equipment in our lab that they don't have, and also it's just good for exchange. Arpan is on a structured PhD program, so he is taking modules remotely as well. I should have said that. So that ties in with what we're doing as well. He will visit in hopefully early 2023, and I'm due to visit out there before the summer as well. And like I said, we're working on this special issue, which hopefully of the journal, which hopefully will be out next month. And then we're also looking at further collaborations. So final thoughts. This is an exciting new avenue for joint research. It definitely, without Run EU, we wouldn't be here. We wouldn't be here talking. We possibly might not have met. It definitely has brought the two of us together, the two institutes together, and has allowed us to start off this research work. In terms of remote supervision, it works well so far. The work is good. We've had no difficulties, no challenges. The usual delays and sometimes like you see today, there might be dropped connections. Those things happen, but that's all fine. And from that point of view, there's probably an upside to the COVID-19 pandemic, that it gave us all a bit of confidence to use this way of working remotely, and certainly made it a lot easier to jump into remote supervision. If we're facing remote supervision 3 years ago where you thought you'd never see the person, it might be a whole different story. So that's me done for now. Let's see, any questions?
Paul, thanks so much. Yeah, very insightful.